Now, before I start, there are certain things that I want to remind you again and again, and I have mentioned it actually in your WhatsApp group and also several times in the class. So there were actually 4 continuous assessments that we did during the semester. And there are some students who have actually not, most of you have not submitted at least one. And I mean, there are two actually practical assessments. The first one is about observing the moon for a month and then submit a short report. And I have given you the format and everything, which is not a difficult one for you to do. And then the second one is about observation session. And few of you have submitted it, but only very few of you have submitted it. And you have the chance to do that again in these days, right? Because those 4 stars that I assigned for you is again appearing now in the sky, because we are going to came back into the same kind of, same time in the year now. And then there were 2 continuous assessments that I did through LMS, and there were few students, some students that I cannot see, records for any of these assessments. Now, roughly you will have 20 to 30% of your final marks will come from this assessment, right? Now, if you haven't done any of those, you will automatically lose those 20 points, which I cannot help with that, right? Because you haven't done anything at all, right? So because of that, I mean, I am giving you the chance for those who have not completed this moon project, and also for the observation session, just try to complete it at least, by within next 1 or 2 weeks, because for the moon, to observe the moon, you normally should have at least a month, right? For a period of month. But now you cannot practically complete the whole thing now, but at least you can get partial marks if you submit, the assignment partially. Because I mean, since practically you cannot, do it for a complete month, for the observation for any report that you are going to submit after this week. So I'm going to put a notice there. Even though you have all the details for a complete month, I am not going to consider that as a month, right? So that's because you cannot practically do it. You have to observe it for a month. And the cutoff deadline, I will set a cutoff deadline for all these assignments, which will be most probably 15th of December. And if any of you have any issue, you can personally contact me. And I have mentioned this several times. And none of you have actually contacted me, except there were 1 or 2 students who came and just talked with me. And there are certain difficulties that they had. So I gave them a chance to submit. And other than that, I have not received any feedback from any student. So I am under the assumption that you don't need to submit those assignments, right? So that's my assumption, because now it has been 1 year now. So these assignments are signed in last February. So you had enough time. Then I have extended it few times. So the cutoff, I will set a cutoff deadline, probably will be 15th of December or something like that, because I need to finish, grade all these things. And I am, still waiting for grading, because some of the students, I was expecting that they will also submit this. So that's the situation of the observation sessions. And then we have actually conducted 2 continuous assessments, MCQ, for 2 continuous MCQ assessments, 1 and 2. And I asked you, for those who could not participate the first one, then I gave you another one, right? And there was a certain students who participated for that, and there are actually few students who have not participated for any of those assignments, and they have not informed me as well why they didn't participate, right? So for that reason, I assume that, I mean, they are okay with that. They probably just do the final exams and try to pass the exam. But what you need to remember is you will only get, 70 to 80% of marks from the final exam, as I have mentioned in the very first day of the class, right? So that is something that you have to remember. If any of you have any problem, like if you need an extra assessment, or if you need need another assessment that if you didn't face any of those two assessments, and if you still need an assessment to complete, if any of you contact me within this week, then I will arrange another one for you. Other than that, I'm going to finalize these marks by the second week of the December, right? So after that, I mean, you cannot do anything, and I cannot do anything as well for those, right? So that is the situation of the continuous assessment. And the other thing is, I can actually give you the names those who have not submitted. I will just probably post a small PDF document with all the details who have submitted, who have not submitted. But if you go to the LMS, you can easily see whether you have submitted or not, and you probably should know whether you have submitted or not, right? And within this week and next week, so those who have submitted the assignments, you will see your marks in the LMS as well. And of course, for the MCQ sessions, you should already see your marks because it's automatically corrected. And then for the observation projects, I have not uploaded the marks for you still, as I was waiting whether there is anybody else that need to submit it. But however, I'm going to start grading in this week, and you should see your grades for these continuous assessments in the LMS probably within coming 2 weeks, right? So that's the condition about the right. So there was another assessment. Now this is asking about this poster. Now this one, actually, I would like if you could submit it on the day when you are coming into the exam, right? So I'm going to collect those on that day. However, I can see that there are certain students, so I'm going to drop your marks. Now there were like 3 assessments. Even before that, the poster, if you need to submit, I will actually announce or give you a date that I am available, that you can come and submit those posters. But the thing is, so there will be that poster as well, which I have mentioned in last February. So I was at least try to submit 2 of those 3 projects, right? Which is the first one was the moon project, and the second one was that small observation session, and the third one is this poster, right? That I have asked you to create. It should be a very small poster, right? Now, please, you need to understand that these are continuous assessment that you can actually use. If you do the work, then you will obtain the marks, right? But however, students are, for some reason, they don't need seems that some of you, don't pay the attention for that. And for the poster, Susit, I will, so that's another assignment that I have made, the poster. So that was also given for you, something back in 8 months ago, something like that. So at that time, I told you that this will be collected once you are back here as a hard copy. Now the reason that now I am going to actually drop one of those assignments when I am marking, which is the lowest grade that you will have. The reason is that I am under the assumption you may also have difficulties these days, some of you, and because of that, there are 3, but I am not going to take all these 3, the marks of the all three observations, when I calculate the grades, so what I am going is I am going to drop the lowest one, right? Now it will be the same for your MCQ 1 and 2 sessions. I am take only one of those, so I'm going to drop the lowest one. So whatever the marks that you have, the lower marks, that will be dropped, right? So that is my policy in grading, and this is just to make things easy for you, right? In case if you have any difficulties, let's say face for the first MCQ session, and if you face for the second one, then you will still have to chance the obtain the marks, right? Now, as a considering the situation that you have in these days, if any of you, if you requested from me for another MCQ assessment, if you were not able to face for the previous two, I still going to give you another one, right? If you need, but you have to. So those who are not here as well, you have to inform me whether you need that or not, right? So if you ask from me, then I will provide one, but you have to do it within this week, right? So let me know within this week. Within this week means today is Friday. Within next few days, let's say by 5th December. So let me take by 6th December. Right? So that is the cutoff days. If you need to do one of these continuous assessments again, who couldn't do it, then you can still request that from me. So I will prepare another one, but that will not be the previous one, right? So you will face another new one, but you will still have the chance to obtain some marks from that, but you have to request for that by 6th December, right? So then in the next week, somewhere in between 6th and 15th, I will arrange another test in the LMS and will ask you to do that, right? So that's and even you, for those who have already completed first 1 and 2, you can also take that, right? If you need. So what I'm going to do is I'm going to take your highest marks, right? So that's how I'm going to grade those. Right? So this is just to make it, a little bit comfortable for you in, within these few days. And right now, let's go back to anybody have any questions? So if I tell what I am telling in Sinhala, මේ continuous assessments ඔයගලන්ට ගොඩක් වැදගත්. මේකෙන් 30% marks එනවා. එතකොට assessments වලට අපි moon project එක කියලා පොඩි project එකක් කරා. ඒක ලොකු දෙයක් නෙමෙයි ඔයගලන්ට කරන්න තිබ්බේ observation session එකක්. ඊට පස්සේ තව stars 4ක් මම observe කරන්න දුන්නා ඔයගලන්ට. ඒක ගැන පොඩි report පොඩි excel sheet එකක් submit කරන්න කියලා. ඊට පස්සේ ඇත්තටම තව පොඩි post එකක් ඔයගලන්ට හදාගන්න එපා planets ගැන. ඔය තුන තමයි මම දුන්නේ. ඒතර ඔය තුනෙන් ඇත්තටම මම ඒ projects තුනේ මම ඇත්තටම එකක් හරි දෙකක් හරි lowest marks ඔයගලන්ට තියෙන එක drop කරනවා calculate කරනකොට grades. ඒකෙන් සාමාන්‍යයෙන් 10% වගේ ඔයගලන්ට හම්බ වෙනවා. ඊට අමතරව MCQ assessments දෙකක් මම දීලා තියෙනවා MCQ 1 and 2 කියලා. ඒ දුන්නේ පළවෙනි එක face කරන්න බැරි අයට දෙවෙනි එක එන්න පුළුවන් නිසා. ඒතර ඒ දෙකෙන් මම ඔයගලගේ lowest grade එක අයින් කරලා highest grade එක තමයි calculations වලට ගන්නෙ. ඒකෙන් ඔයගලන්ට 10 to 20% final exam එකට හම්බ වෙනවා. දැන් මේ මට පේනවා ඇත්තටම මේ ඔයගලගේ reports බලුවට පස්සේ සමහරක් අය ඉන්නවා මේ එකක්වත් submit කරලා නැති අය. එතකොට ඒගොල්ලන්ට අර 20% marks ගන්න ක්‍රමයක් නැහැ. ඒක 0 වෙනවා. ඒකට 80 වෙන තමයි අන්තිම final exam එකට ඔයගලන්ට ලියන්න වෙන්නේ. right 80 හෝ 70. සාමාන්‍ය 70 වෙන එක තමයි policy එක. right and අනිත් එක තමයි ඔයගලන්ට කාට හරි දැනටත් time එක තියෙනවා මේ observation projects දෙකක් දැනට මේ stars 4ක් observe කරන්න පුළුවන්. ඊට පස්සේ මේ moon project එක කරන්න පුළුවන්. මේ ඒ projects තුනෙන් ඇත්තටම මම දෙකයි ගන්නෙ. මම කලින් කියපු එක correction එකක්. ඒ කියන්නේ එකක් ගන්නවා එකක් මම drop කරනවා. ඒ කියන්නේ lowest marks ඔයගලන්ට තියෙන එක. right poster එකයි moon project එකයි observation session එකයි. ඔය තුනෙන් මම එකක් drop කරනවා. මම grade කරාට පස්සේ lowest mark කියන එක අයින් කරනවා. අනිත් දෙක අරගන්නවා. MCQ sessions දෙකක් මම කරලා තිනවා. ඒ දෙකෙන් lowest marks ඔයගලන්ට තියෙන එක අයින් කරනවා. අනිත් එකම අරගන්නවා. එහෙම තමයි සාමාන්‍ය procedure එක. නමුත් මේ අවස්ථාවේදී ඔයගලන්ට කාට හරි සමහරක් අයට මම දන්නවා ප්‍රශ්න තිබ්බා signal ප්‍රශ්න ඒ වගේ කාටද තිබ්බනම් දැන් ඔයගොල්ලෝ මෙහි නිසා request එකක් කරන්න පුළුවන්. මගෙන් තව ඔයගලන්ට ඇසෙස්මන්ට් එකක් ඕනේ නම් මට අතර WhatsApp එකකින් ඔයගොල්ලෝ මැසේජ් එකක් දැම්මත් මම ඒක කන්සිඩර් කරනවා නැත්නම් මට ඊමේල් එකක් දාලා හරි කෝල් එකක් දීලා කියන්න ඔයගලන්ට කරන්න බැරි වුණා සහ හේතුව මොකක්ද කියලා. එතකොට මම එහෙම කවුරු කීප දෙනෙක් ඉන්නවනම් මම තව MCQ session එකක් ඕපන් කරන්නම් ඔයගලන්ට. එහෙනම් මම ඕපන් කරොත් ඒක ඕපන් කරන්නේ ඔක්කොටම. එකිනෙකට දෙන්නෙකුට නෙමෙයි. ඒක එක ටයිම් පීරියඩ් එකක් දෙනවා ඔයගලන්ට කම්ප්ලීට් කරන්න. නමුත් ඒ අවස්ථාවේදී මම ඇත්තටම ගන්න ඔයගලගේ lowest marks මම drop කරනවා කියන එක. අනිත් එකක් තමයි ඔයගලගේ grade එකට ගන්න continuous assessment විදියට. ඒතර ඔයගලගේ lowest කියන අඩු ලකුණු තියෙන එක මම drop කරනවා. Right? But that happens only if somebody who has not completed any of these MCQs, if they need to do it, මේ MCQs දෙකෙන් එකක්වත් complete කරන්න බැරි කවුරුහරි ඉන්නවනම් මට request කරොත් මට ඒක consider කරන්න පුළුවන්. Right? But you have to do it. අඩු ගන්න December 6ට කලින් මට කියන්නේ නැත්නම් මම මේ marks finalize කරනවා. Right? හරි. වෙන මොනවද ඔයගොල්ලෝ ප්‍රශ්න තුන මගෙන් අහන්න මම මේ revision session එකට යන්න.
Sir, excuse me, sir.
Oh, Susi. Yes.
Sir, අපි මේ exams paper එකේ structure එක දෙන්නේ sir MCQ structure essay විදිහටද?
Oh, right. So මම ඒක කියන්න ඔයගලන්ට your exam paper structure will be there are 60 questions in the exam paper. There will be 24 MCQ questions. පළවෙනි ඔයගලන්ට ප්‍රශ්න 60ක් තියෙනවා paper එකේ. So there are 2 hours පැය දෙකක් තියෙනවා. ඊට පස්සේ පළවෙනි ප්‍රශ්න 24 MCQ ප්‍රශ්න 24ක්. එතකොට මේ MCQ වහන්නේ ඔයගලගේ මේ උගන්වපු ටික ඔක්කොම ආවරණය වෙන විදියට. MCQs ප්‍රශ්න 24ක් තියෙනවා. ඒ හතරට උත්තර දෙන්න ඕනේ. ඊට පස්සේ ප්‍රශ්නාංක 25 ඉඳන් ප්‍රශ්නාංක 44 වගේ වෙනකන් structured. ඒ කියන්නේ ඔයගලන්ට paper එකේම ඉඳ තියලා තියෙනවා. There will be space in the paper. So you have to write the answers whatever the questions that are asked, right? For example, I could ask like why you have different phases of the moon. So I just expect only one or two sentences maximum, right? ඔයගලන්ට ඒක රචනා වගේ ඡේද ගණන් ලියන්න ප්‍රශ්න මම අහන්නේ. So there will be one or two sentences maximum that you have to write. වාක්‍යයක් දෙකක් වගේ තමයි ගොඩක් වෙලාවට ලියන්න වෙනවා. So I will actually explain you some of these things in the revision session as well, what kind of things that are important. I mean, everything is important what you have learned, but I can summarize what we have done. Prashnanka, from question number 25 to question number 44. So those will be short answer questions, right? Why you have different phases in the moon and when will you have let's say now you know that about the solar eclipses and lunar eclipses, and you know that the solar eclipses do not happen in full moon days. It has to be a new moon day, right? For the lunar eclipses it has to be a full moon day. Those kind of questions, right? And why you have different seasons and those kind of things. So these are like, students who completed this astronomy course, I expect certain things that they should know, right? So those are actually now once you go out and if somebody asks you why do you have different seasons, I expect that you should know it, right? So those kind of things I would like that you those will be tested. So that's what will happen. About the details about the solar eclipses and the lunar eclipses. Why do you have a solar eclipse and how does that happen? What kind of solar eclipses that you normally observe and what is a lunar eclipse? මේවා අපි සාමාන්‍යයෙන් අපි ඔයගලන්ට අපි සාමාන්‍යයෙන් ඔය එළියට ගියාට පස්සේ එක්ස්පෙක්ට් කරන knowledge එක සාමාන්‍ය astronomy course එකක් කරපු කෙනෙක්ගේ, right? කවුරුන් ඒවත් කියන්න ඔයගලන් දැනගෙන ඉන්න බෑ. So those things will be tested, but it will go into, of course, a little bit higher level. So short answer questions and also small calculations, how to find the magnitude of a star and distance to a star given the parallax. So I will just discuss, revise some of these things I have done. And the next thing is And starting from question number, me take question number 45 to 60. Still, you have to, those are structured type questions. ප්‍රශ්න 45 ඉඳන් 60 වෙනකන් තියෙන structured ක්‍රමයේ ප්‍රශ්න. ඒ කියන්නේ short answers ලියන්න තියෙන්නේ. නමුත් ඒ වගේ සමහරකට ටිකක් calculate කරන්න තියෙනවා. Like for example, like find the, let's say, the Schwarzschild radius of a black hole, those kind of things. Find the magnitude of a star and calculating the age of the universe. Those kind of calculations that we did in the class. So I'm going to test you whether you can do those things. The idea is, මම ඇත්තටම ඔයගොල්ලෝ විස්තර කරන්න නම් අයි මේව ටෙස්ට් කරන්න කියලා. දැන් ඇස්ට්‍රොනොමි කරපු ස්ටුඩන්ට් කෙනෙක් විදිහට එළියට ගියාට පස්සේ සමහරක් පොඩි මේ සරල calculations තමයි මම ඔයගොල්ලන්ගෙන් අහන්නේ. නැතුව මම I am not going to ask you to solve the Einstein equations or something like that, right? So because those are higher levels that only special degree students are needed. So those things I am not going to ask. මම ඔයගොල්ලන්ගෙන් Einstein සමීකරණ විසඳන්න අහන්නේ exam එකේදී. So what will be asked is just very simple things, very basic physics, right? And basic equations, how to find the magnitudes of the star, and then Kepler's laws. Now Kepler's laws are important when you talk about the movements of the planets. Those kind of things are important. Now so that will be the structure of the paper. ඒක තමයි structure එකේ. මම සිග්නල් එකත් කියන්නේ ප්‍රශ්න 60ක් තියෙනවා. පැය දෙකක් ඔයගලන්ට හම්බ වෙනවා. පළවෙනි ප්‍රශ්න 24 MCQ, 24 ඉඳන් ප්‍රශ්නාංක 60 දක්වා තියෙන ඔක්කොම ප්‍රශ්න structure type එකේ. ඒකම ප්‍රශ්නාංක 25 ඉඳන් ප්‍රශ්නාංක 44 වෙනකන් තියෙන ප්‍රශ්න ඔයගලන්ට ඇත්තටම ලියන්න තියෙන short answers, සාමාන්‍යයෙන් short answers සහ calculation එකක් තිබ්බොත් ඉතාලම basic calculations තියෙන්නේ. Calculator එක සමහරක් වෙලාවට ඕන වෙනවා. ඒක provide කරනවා. Very basic calculations like how to apply the Kepler's third law, those kind of things, right? Kepler's ගේ තුන්වෙනි නියමය apply කරන්න ඕන. මේ වගේ හරිම basic calculations තමයි තියෙන්නේ. ඊට පස්සේ ප්‍රශ්නාංක 45 ඉඳන් 60 වෙනකන් structured ප්‍රශ්න තියෙන්නේ. නමුත් ඒක පොඩි සමහරක් වෙලාවට ටිකක් කරට වැඩි චුට්ටක් සමහරක් වෙලාවට ලියන්න තියෙනවා. නමුත් there is no large difference, right? ඕක තමයි සාමාන්‍ය structure එක paper එකේ. තවත් මොනවද ඔයගොල්ලන්ට දැනගන්න structure එක ගැන paper එකේ කාට හරි ප්‍රශ්නයක් තියෙනවා නම් අහන්න. You can ask any question. Right, so if not, let me actually just go through what we have done very briefly, and I will like highlight some of the things that may be important for you. So let me share. මම මේ කරන අතරේ ඔයගලන්ට කාටද ප්‍රශ්නයක් තියෙනවා නම් you can ask anything, right? Right, so I'm going to share the LMS window with you. Right, so I expect that all of you can see. Let me just switch off the video in case, just to make it clear. Right, now you can see the LMS page, and there is syllabus and course content. And then if I go to the first set of lectures that you had, this is just a very introductory section. So there is actually nothing special that I can tell you about this particular section, rather than this is a very basic introductory section. It's about kind of an overall picture that what we are going to, what we have taught. And then from the second lecture, so this is where you can see that I have assigned you this moon project right now. This is so I have said the due date for the moon project is 10 December, Friday. So make sure that if any of you have any project that you have completed and still did not submit, you have the time until 10 December, right? So I will still accept the full project, assuming that you have done it completely. But after that, until let's say 20th, so I will set another deadline that let's say 15 December or something like that. Those who still continue it from today, you can at least go through the halfway and obtain the half of the points, because you do not have a full month now. So I will set another deadline for that. I mean, all these things are done for, just to give you another chance to submit these considering the situation. And the second lecture is about the birth of the astronomy. And now certain things that you need to pay your attention is these locations, right? මේ locations අර්ථ දක්වලා තියෙන විදිය හරි වැදගත්. So you need to know what is your zenith. Zenith is the, so when I tell zenith, let's say in an exam paper, you need to understand what zenith means, right? Zenith is the point directly above your head, and the horizon you already know, right? So these locations are important, and then you should have an idea about the celestial sphere. Again, the zenith is the point directly above your head and your horizon. Those things you should know at least. And then so we have talked what is celestial equator, and this is how stars move, with and this is something very, very, very interesting, and something that new that we have talked. The stars, if you are at the North Pole or the South Pole, during the course of night, all the stars will circle around the celestial pole, none rising or setting. මේ කියන්නේ ඇත්තටම මේ stars ඔයගොල්ලන් North Pole එකේ ඉන්නවා නම් stars ඔයගලන්ට rise වෙනවා හරි. ඒ කියන්නේ අපි සාමාන්‍යයෙන් කියන්නේ තරුවක් නේ, කියන්නේ ඉතින් පායලා බටහිරින් බහගෙන යනවා කියලා. නමුත් එහෙම වෙන්නේ නැහැ. මේ North Pole එකේ ඉන්නවා නම් ඔයගලන්ට පේන stars circle වෙනවා මේ North Star එක වටා. ඒ කියන්නේ ඔයගලගේ උඩ zenith එක වටා මේ ඔක්කොම මේ තරුව ඇත්තටම circular pattern එක ගමන් කරනවා වගේ තමයි පේන්නේ ඔයගලන්ට. ඒ කියන්නේ stars කවදාවත් පායන්නේවත් බහින්නේවත් නැහැ ඔයගල North Pole එකේ ඉඳන් බලනකොට. So what I have explained here is how the sky looks like for different locations, so how it looks like for, when you are in the celestial equator like that. Now this is very important, right? In practical astronomy, sky at different locations on the earth is very important, especially if so this is something that that is very important for the practical purpose. If you are at the latitude of 38 degrees north, so that means your location, and since you are using Google Maps, you should know this information. The north celestial pole is 38 degrees above the northern horizon. Now this tells you where is your north pole with respect to your location. So what is important here is wherever you are, your latitude is equal to the latitude of the celestial North Pole, and this is true for the South Pole as well. So I have specifically mentioned the North Pole here because we are in the northern hemisphere. For example, now our latitude is around 5 degrees. That means our celestial North Pole should be around 5 degrees above the horizon, or the latitude of the North Pole is like 5 degrees. So those numbers are equal, right? So that is something that you have to, know from your knowledge and from the experience. So those are the things that sometimes important for you to remember. So that's why I have mentioned it here. Now the southern hemisphere, it is the same case. So I have just put a number here, 38 degrees north, but it's it doesn't matter the latitude, your location, whatever is your location, the north latitude of the North Pole will be similar to that, right? So that's how you take that. And here is something very, very special that I have taught you. So that is now if when you have an observer at a 38 degrees north latitude, what happens is the stars within 38 degrees of the North Pole can never set. So which means, think that you are at a latitude of 38 degrees, then your North Pole is 38 degrees above the horizon, or your latitude is the North Pole is, the latitude of the North Pole is 38 degrees. And there is a region actually on the sky that the region in the sky that when you consider that particular region, stars within that region never rise or set. ඒ කියන්නේ මේක region එකක් තියෙනවා. දැන් මේක ඇත්තටම හොඳටම පේන්නේ ඔයගලන් ටිකක් වැඩි latitudes වලට ගියොත් දැන් උදාහරණයක් විදිහට අංශක 40ක් latitude එකක් තියෙන රටකට ඔයගලන් ගියොත් මේ එතකොට ඔයාගේ north pole එක තියෙන්නේ ඇත්තටම North Pole එකේ latitude එකත් අංශක 40ක් වගේ වෙනවා. ඒ කියන්නේ horizon එකේ නම් අංශක 40ක් උඩින් තියෙන්නේ. එතකොට ඒතර region එකක් තියෙනවා. මෙයා North Pole එක වටා තියෙන region එකක් තියෙනවා. ඒ region එකේ තියෙන stars හැමතිස්සෙම ඉන්නේ above the horizon. ඒ කියන්නේ ඒවා කවදාවත් stars අපිට නැගලා බහලා යනවා කියලා කියන්න බෑ. ඒ region එකේ තියෙන stars කවදාවත් කියන්නේ නැගලා බහලා යනවා කියලා එකක් වෙන්නේ නැහැ. ඒව circular pattern එකක තමයි ගමන් කරන්නේ. ඒකට මේ special region එකට අපි නමක් කියනවා circumpolar zone කියලා. මොකද මේ zone එක ඇතුලේ තියෙන stars කවදාවත් කියන්නේ we used to say that those stars never rise or set, right? So that is the idea. So that's something that we learned. And for an example, if you look consider a country like United States, which is a little bit higher in latitude, around 40 degrees north, these constellations, so there are 2 constellations that I have, 3 constellations, Big Dipper, Little Dipper and Cassiopeia. So they are examples of star groups in the north circumpolar zone. You can may Tarurata, මේ constellations ඇත්තටම ඔයගොල්ලන් US ඒ වගේ රටක ඉන්න බැලුවොත් මේවා කවදාවත් ඒ කියන්නේ නැගෙනහිර පායලා බටහිරින් මෙහාට යන්නේ නැහැ. මේක ඇත්තටම circumpolar zone එක ඇතුලේ තියෙන නිසා මේවා they never rise or set, right? So that's an example. මේක ඇත්තටම මම විශේෂ දෙයක් ඔයගොල්ලන්ට උගන්වනවා. So that's why I want to just to stress about it. And then I mean those things are important, right? So I just mentioned, I mean it doesn't mean that others are not important. Some of the things that I felt that I should specifically tell you. And then, so if I go to the next section, sorry, the 2 we talked, and let's go to the 3rd lecture, chapter 3. And these are actually aligned with the book as well, the first few chapters. Now this is about actually orbits and gravity, so which means this chapter basically teaches you some of the physics concepts that we are going to use to explain the motions of these celestial objects. අපි මේ chapter එකෙන් අතරම කරේ මේ භෞතික විද්‍යාවේ පාවිච්චි වෙන basic principles මොනවද අපි use කරන්නේ මේ celestial bodies නැත්නම් අහසේ තියෙන තරු ගහඩෝක වගේ දේවල් වල චලිතය විස්තර කරන්න කියන එක තමයි සාකච්ඡා කරේ. Now this is one of the very important topics. So I have discussed I have discussed about the Kepler's laws in detail here. So I am not going to explain it again because we do not have much time. But this equation is important. Right? This is Kepler's 3rd law. Right? How the length of the semi-major axis is related to the period. So make sure that you have a good understanding about Kepler's law and also these different forms. Right? Now you can see that I have mentioned here p squared proportional to a to the power 3 here. However, if you use correct units, so that is, if you measure p, that is the orbital period in years, and if a is expressed a quantity called astronomical unit. And since we have done all the lectures now, you know what astronomical unit means. The two sides of the formula are not only proportional but equal. ඒ කියන්නේ ඔයගොල්ලන් මේ කෙප්ලර්ගේ තුන්වෙනි නියමය පාවිච්චි කරනකොට මේ orbital period එක years වලින් බැලලා distance එක semi major axis length එක astronomical unit වලින් බැලුවත් මේ equation එක මේ දෙකට සමානයි. Now just to let you know, I am not going to give you these equations in the exams because these are very basic equations. මේ equations අතර ඔයාලට විභාගයක් දෙන්නේ නැහැ. මේ මතක තියෙන්න ඕන. Right? Okay, plus law. This is a very simple equation. So make sure that you remember it. Now this third law applies to all objects orbiting the sun, including the earth. සාමාන්‍ය මේ කෙප්ලර්ගේ තුන්වෙනි නියමය apply කරන්න පුළුවන් ඕනම object එකකට. Planets, comets, ඒ වගේ ඕනි එකකට අපේ කියන්නේ සෞරග්‍රහ මණ්ඩලය ඇතුළේ තියෙන. So I have mentioned two examples here with an examples, you know, පොඩ්ඩක් ඔයගොල්ලන් ඒ example study කරන්න, and I have given you the answers for the examples as well. So it should not be that much hard for you to study these. So I am sure you will have to use Kepler's law in the exam, right? So there is no question about that. So that will be tested. ඔයාලට මේ Kepler law එක පාවිච්චි කරන්න පුළුවන් ද කියන එක ටෙස්ට් වෙනවා සාමාන්‍ය exam එකේදී. So make sure that you have a good understanding how to use it. Most of the time, from my experience, what I have seen is that students try to make this because you have not properly studied or not properly used it few times. Students try to make things very complicated when I ask question to use Kepler's law, because it's very clear that if you use the orbital period in terms of years and the distance in terms of astronomical units, the usage of the equation is very easy, right? For example, now I have given you orbital period of the object. I'm asking the orbital period given that the length of the semi-major axis is 50 astronomical units. And what students try to do is they try to convert this to kilometers or something like that and make things complicated, which you don't have to do that, because when you submit A in terms of astronomical units, your answer will automatically come in terms of years, right? So those are those kind of things that you have to, you know, understand. And also, apart from doing these mathematical calculations, you should also understand that the effect of the Kepler's laws. For example, according to the Kepler's second law, also that when you have, let's say, the sun is at the center, since when all these planets are moving in an elliptical orbit, when a planet gets closer to the sun, it should move faster, right? According to these laws. And so just think about those kind of things, right? So those are like examples, and I have given you the answers here as well. So you can just look at that, and I have summarized the Kepler's first law, second law, and third law. Remember that I am not going to ask you these laws, right? So don't try to, you know, memorize the laws, but you need to know that equation that you are going to use and how to use it, right? මම Keplerගේ දෙවෙනි නියමයේ කුමක්ද ඒ වගේ ප්‍රශ්න I am not going to ask you from the exam, right? ඒ වගේ ප්‍රශ්න අහන්නේ exam එකේදී ඔයගලන්ට ඇත්තටම මේවා use කරන්නේ කොහොමද කියන එක තමයි වැදගත්. සම equation එක ඒකට ඔයගොල්ලෝ මතක තියාගෙන ඉන්න ඕනේ, use කරන්න ඕනේ. So that is the important thing. And then so I have some other, you know, conservation of angle. These things you already know, right? So I'm going to explain it. And this is something that you need to be careful here. So this is called Newton's version of Kepler's third law, which means once you think about the Newton's formula, it introduces additional factor of the mass. So if you have the masses of the sun and the planet as m1 and m2, which are expressed in the units of solar mass. So these units are very important. So that's why I'm emphasizing these things. Right? units හරිම important astronomy වලදී. Units ඔයගොල්ලෝ මාරු කරොත් calculations complete වෙනවා, complex වෙනවා, ඊට පස්සේ ඔයගොල්ලන්ට කරගන්න අමාරුයි. ඒ වගේ ප්‍රශ්න එනවා. සහ හරි උත්තරේ එන්නේ නැහැ. ඒ නිසා මේක හරිය වැදගත්. මේ තියෙන්නේ නිව්ටන්ස් version එක කෙප්ලර්ගේ තුන්වෙනි නියමයේ. ඒකට අපි හිතුවත් සූර්යයා සහ තවත් planet එකක් ස්කන්ධය M1 and M2 කියලා මේ ස්කන්ධයන් solar masses වලින් මැන්නොත් අපිට මේ equation එක මේ නිව්ටන්ස් version of the Kepler law එක ලියන්න පුළුවන් මේ විදිහට. මම අතරම යට කියලා දෙනවා මේකයි කෙප්ලර්ගේ මේකින් වෙනස් වෙන්නේ කියලා. දැන් අපි ගත්තොත් එහෙම මේ විතර ලිව්වට මේක තියෙන ඇඩ්වාන්ටේජ් එකක් තමයි මේ නිව්ටන්ස් version එක අවශ්‍ය වෙලාවට පාවිච්චි කරන්න පුළුවන් අපිට. මේක එක mass එකක් ගොඩක් වැඩිනවා. For example, if you think about a very small planet and the sun, you can neglect the mass of the planet. But the way ස්කන්ධය වැඩි නිසා එතකොට මෙතනින් පුළුවන් you have the chance to find the mass of the sun sometimes, right? So those kind of things that you can do. Application එකක් තමයි මේකේ we use this Kepler's Newton's form of the Kepler's law to find the mass of the Jupiter by considering the motion of one of the moons around Jupiter. සමහරකට අපි මේ බ්‍රහස්පති ග්‍රහයේ වටේ යන moon එකක් consider කරලා ඒ moon එකේ orbital period එක calculate කරලා මේ equation එක යොදා ගන්නවා Jupiter ගේ mass එක හොයන්න. ඒ කියන්නේ planet එකේ mass එක හොයන්න. ඒ වගේ දේවල් කරන්න පුළුවන් අපිට. Right. So that's what I have explained here. And there are certain, about some of these details about the asteroids, which is again follow this Kepler's law. And something that you probably notice is when this if you think about a path like this, when a comet or the asteroid get closer to the sun, they will move faster, right? Because their length of this semi-major axis decreases, and according to the Kepler's second law, you will see that they say that equal time they sweep out equal area. So to do that, when this distance is smaller, it will quickly move through the orbit, right? So those kind of things are probably important to know, and that's about yes. So those things are very important. So that's why I emphasize about those you. So make sure that you go through and look at these points that I have mentioned, right? And the other thing is the chapter 4. Let me go to the chapter 4. Next one. And this is about the motion of the Earth, Moon, and how the objects that are in the sky, they are moving. And I guess this gives you some information about locating the places in the sky. And I have mentioned that normally we use right ascension and declination as units as a standard when you locate objects in the sky. The reason is actually we normally use latitudes and longitudes for local observations, but when you go for observations, when you are doing astronomy research or something like that, we use this right ascension and declination. The reason is that those values will not change from one location to the other location. So that measurement is independent of the location. If you, for example, if you need to locate an object, you go to these databases and try to find the right ascension and declination of that particular object. It will not change from one location to the other location. So those are fixed, right? And so that details is there. And then seasons that I have told you, how seasons occur, and something that you need to be very sure is what actually causes the red seasons, right? So this is something, even after you get your degree, sometimes students do not know why you have different seasons, right? I mean, this has been teaching, I guess, from grade 6 or something like that. So make sure that you have this basic, the basic knowledge, right? All right, so that's something that we have talked. And so all this information about, the seasons. And I know that you cannot, take all these things, but at least make sure that you know why you have seasons, right? අපිට වෙනස් ඍතු තියෙන්නේ මොකද කියන එක ඔයගොල්ලන් පැහැදිලිව දැනන් ඉන්න ඕනේ. මොකද හේතුව කියන එක, right? And the other thing is, this is something important for you in practical observations, sidereal day and solar day. මේක ඇත්තටම මම ඩිස්කස් කරා. මේක sidereal day එකක solar day එකක තියෙනවා වෙනසක්. මිනිත්තු 4ක මේ මිනිත්තු 4 වෙනස නිසා ඇති වෙන ඉෆෙක්ට් එකක් තියෙනවා. So that effect is given right here. මේක ඇත්තටම practically use වෙනකොට අපි හිතුවත් එහෙම දැන් මේ serious කියන්නේ star එකක් අපි මෙයා පැය 7ට magnitude පායන්න ගන්නවා කියලා අපි හිතුවත් එහෙම in the location එකේ ඊළඟට අපිට දැනගන්න ඕන නම් තව මාස 3කින් දවස් 90කින් මේ serious star එක ඇත්තටම මේ පායන්නේ කීයකද කියලා අපිට මේක හොයාගන්න පුළුවන් මේ වෙනස නිසා sidereal day එකේ solar day එකේ වෙනස. එතකොට මේ මිනිත්තු 4ක වෙනසක් තියෙනවා. මේ මිනිත්තු 4ක වෙනස නිසා මේක sky එකේ මෙන්න මෙහෙම දෙයක් වෙන්නේ. එතකොට දවසකට මිනිත්තු 4ක වෙනසක් වෙනවා. එතකොට මේක 90 days යනකොට මොකද වෙන්නේ මිනිත්තු 360ක වෙනසක් වෙනවා. ඒ කියන්නේ පැය 6ක වෙනසක් වෙනවා මේක rising time එක. right? ඒ කියන්නේ මේක පැය 6ක් කලින් තමයි මේ කරුව ඇත්තටම පායන්නේ. right? මේ වගේ calculation එකක් ඔයගලන්ට දුන්නත් කරගන්න පුළුවන් වෙනවා. ඒ කියන්නේ මේ මිනිත්තු 4ක් කියන්නේ මේකේ practical application එක තමයි ඔයගලන් star එකක් බැලුවොත් දැන් ඒක අද පායන්නේ හවස 6ට නම් හෙට මේක ඇත්තටම theoretically මේකෙන් පායන්න ගන්නේ 5:56ට විනාඩි 4ක් පහු වෙලා. මේක තමයි හැම star එකකටම වෙන්නේ. ඒත් මේ වගේ calculation එකක් ඔයගලන්ට කරගන්න පුළුවන් වෙනවා. right? So this the delay in 4 minutes a day that comes as a result of this difference in the solar day and the sidereal day. But the application is this. මේක තමයි application එක. ඒතර ඇත්තම වැදගත් වෙන්නේ මේක. right? මේ වගේ calculation එකක් විතර මම ඔයගලන්ට I expect that you will able to do that. So I have an example here as well. If a star rises at 8:30 p.m. tonight, approximately what time will it rise 2 months from now? මාස දෙකකින් පස්සේ කියන්නේ අටමාට නම් දැන් අද රැයට එක්තරා තරුවක් පායන්නේ හසේ. ඒ කියන්නේ අතර දවස් 60ක් මාස දෙකකින් පස්සේ දවස් 60කින් පස්සේ එක දවසක විනාඩි 4ක ඩිලේ එකක් වෙනවා. එහෙනම් මේක පැය 4ක් ඩිලේ වෙනවා. කියන්නේ පැය විනාඩි 240ක්. ඒ කියන්නේ පැය 4ක් ඩිලේ වෙනවා. ඒ කියන්නේ 8:00ට පායන්න ගන්න තාවතාව ඊළඟට තව මාස දෙකකින් 4:00ට තමයි අපි එන්නේ. ඒතර මේක ප්‍රැක්ටිකල් සිටුේෂන් එක තමයි 4:00ට. So you have the sun at that time, so you will not be able to see it, but when it get dark you will suddenly see that this particular star is right up on the sky. මේක පාට ඔයගලන්ට පේනවා ප්‍රයාස පැහැදිලිව පේන්නේ. Right? So that's what happens because at 4:30 you cannot see it now. Make so this is something that you should pay your attention, I guess, right? And then I have some of these things what happened to the moon and phases of the moon. Then I have here the details about why you have eclipses. So we actually discuss how a solar eclipse occurs and different types of solar eclipses. And so that is something. The solar eclipse normally happen in a new moon day. ඇත්තටම මම සමහරක් years වල දෙකක් කරනවා ළමයි ඉගෙන ගත්තට පස්සේ මේක දන්නෙත් නැති අය. ඒ කියන්නේ solar eclipse එකක් වෙන්න බෑ full moon day එක. Right? So those are like basic things that you should actually know. Lunar eclipse normally happen in a full moon day, and these are day-to-day things that you should know. Right. So that's lecture 4, and then lecture 5, chapter 5. in chapter 5, actually, what I was trying to talk is the next important thing is, in astronomy, there are two things that comes into play. So that is how objects move on the sky. And there are different laws in physics that you need to understand, especially the Kepler's law. So that's what we have discussed in the previous chapter. And this chapter, actually, we talk about how the light behaves. Because light and the other waves coming from the electromagnetic spectrum. So those are the basic, that is the basic element that we use in astronomy. ඇත්තටම තාරකාවිද්‍යාවේ පාවිච්චි කරන ප්‍රධානම දේ තමයි මේ කොහොමද objects move වෙන්නේ සහ ඒව දිහා බැලුවට පස්සේ අපිට observe කරන්න පුළුවන්. ඒක observations වලට අපිට ඇත්තටම ඕනි වෙනවා මේ දැනගන්න මේ කොහොමද අපේ electromagnetic spectrum එක අපි පාවිච්චි කරන්නේ කියන එක. සහ ඒකෙන් අපිට ගන්න පුළුවන් details මොනවද කියන. ඒතර මේ ඇත්තටම මේ chapter එකේදී අපි ඒක කතා කරේ. How light behaves, and that when you with the increasing distance, you get less amount of light for a square meter or square centimeter. And this explains how the electromagnetic objects in the universe, why you have different telescopes at different locations, making අතරම පැහැදිලි කරන්නේ ඇයි අපි different telescope එකක සමහරක් ඒවා space එකට යවනවා. Then උදාහරණයක් විදිහට you can see that these rays coming from the X-ray and gamma ray, so they don't normally reach to the earth, right? ඒවා පොළොවට එන්නේ නැහැ මොකද they get absorbed from the atmosphere. And because of that, if you want to build an X-ray telescope where you use X-rays to observe objects, you have to put that into the space. So that's why X-ray telescopes like Chandra X-ray telescope, they are in the space, like not on the earth. And similar for the infrared, you cannot observe it from the earth. And interestingly, there is a plane that I have here, right, for the IR region, right? I mean mid to low IR region. So that is because infrared observations can be made. You don't need to go for the space, but it is easier to make these IR observations in high altitudes. And because of that, there is actually one observatory that is built up in a Boeing jet. මේ Boeing jet එකක් ඇතුලේ build කරපු observatory එකක් තියෙනවා. මේක ඇත්තටම අපි කියන්නේ සොෆියා කියලා. මේක ඇත්තටම කරන්නේ ටෙලස්කෝප් එක ඇතුලේ මේ jet එක ඇතුලේ තමයි ටෙලස්කෝප් එක තියෙන්නේ. මේ jet එක ඇත්තටම move වෙනවා ලෝකෙ හැමතැනටම. මේ ටෙලස්කෝප් එකත් අරගෙන මේක තමයි එකම මම දන්න ඇත්තටම එකම අවස්ථාව මේ moving observatory එකක් jet එකක් ඇතුලේ තියෙන. මේක NASA එකෙන් තමයි ඇත්තටම control කරන්නේ. I think I should have this information later, and this is some details about the electromagnetic spectrum. මේ ඇත්තටම මම මෙතන පෙන්නලා තියෙන්නේ මේ electromagnetic spectrum එකේ විවිධ කොටස් අපි පාවිච්චි කරන්නේ කොහොමද කියලා. Radiation එක. And this is very important. Once again, the Wien's displacement law, maybe Wien's displacement law කියන එක ඇත්තටම ගොඩක් වැදගත්. I think we are almost, the time is almost 9:01. I was wondering, let me know if you have any lectures at 9, right? So if not, I will probably continue for 5 to 10 minutes just to finish this section, right? Please have a message for me, or just unmute your mic and let me know if you have a lecture. And I assume that you don't, because now you don't have practicals today. So let me just continue for another 5 to 10 minutes to finish this section, right? So then nextly I can take the other sections and summarize to you what we have done, right? So which will be easier for you at the end. Right. Now, when you talk about electromagnetic radiation, there is a relationship between the temperature and the radiation, which means, so I have a question here. What determines the type of electromagnetic radiation emitted by the sun, stars, and other dense astronomical objects? මේ මොන විදිහේ electromagnetic radiation එකක්ද මේ විවිධ වස්තු වලින් emit කරන්නේ අපිට කියන එක ඇත්තටම decide කරන්නේ ඒ object එකේ temperature එක. Right? So there is a clear relation between the temperature and the type of electromagnetic radiation that you will receive. Right? And the reason is actually the Wien's law. Wien के विस्थापन नियम කියලා ඔයගොල්ලෝ ඉගෙන ඇති. So the reason is actually when you look at the higher the temperature, when you can see here that when temperature increases, the maximum intensity wavelength is shifted towards a lower wavelength. So what this means in astronomy is that, for example, if you have an object that is clearly, let's say, visible in around blue color, it looks blue, so that means the temperature of that particular object may be around 6000 Kelvin. So you can get that kind of idea. ඔයගලන්ට මේ radiation එක temperature එකට සම්බන්ධ කරන්න පුළුවන් මේ විදිහට. Now the equation that connect the radiation and the temperature is actually Wien's law, මේ Wien's විස්ථාපන නියමය. Now here also I am not going to give you any of these equations. මේ Wien's විස්ථාපන නියමය ඔයගලන්ට exam එකේදී පාවිච්චි කරන්න තියෙන නියමය මේකයි කියලා දෙන්නේ නැහැ. So you need to remember it because these are like basic laws. Because of that, you need to remember it, but the constant will be given. What is the constant? This is called Wien's constant, 3 times 10 to the power 6. That constant I will give, right? What is the constant that you have to use? Other than that, this is how the maximum wavelength is related to the temperature, and this is Wien's displacement law is very important because it will decide how the temperature is related with the radiation, right? And for sure you will have, I know you have to use Wien's displacement law at least one time in your exam paper. I mean, that's sometime, I mean, normally happens always because you can see that it's a basic law that you have to use, right? And I have given you 2 examples here. For example, you have a red dwarf star that has a wavelength of maximum power at 1200 nanometer. Then you have to estimate the temperature. Now this is how the Wien's displacement law is used in astronomy. I mean, I think these are like simple calculations that everyone can do. So I am not going to explain you how I have done because it's just straightforward, right? There are examples and I have shown you how the examples are done. So you can use the same. And then the next law is Stefan Boltzmann law that again relates the temperature and the energy flux of a star or any kind of astronomical object. And normally this is the form that we use, assuming a spherical shape. For example, for a star, if you assume a spherical shape, luminosity of a star can be written in this form. And this is a different version of the same Stefan Boltzmann law. This 4πr squared means the area of a sphere, assuming that you have the spherical shape, and t to the power 4. Now this tells you a luminosity of any object, including stars, depend on the surface area and the temperature, right? So that is something that you have to remember, or you need to know, like how the luminosity is related to the temperature and the surface area. And I have given you an example, the 2 stars with 2 different temperatures, and I'm asking how much they have the same size but different temperatures. Then you can decide what is luminous compared to the other one. So that calculation is done here. These are, very simple calculations, so I'm not going to explain you, but the examples are given for a reason here, which means I expect that you should know how to use these equations, right? And then there are, what's continuous spectrum and different types of spectra, and I'm not going to go through those because I think you probably have learned these things. And this Doppler formula is something that I expect that you should remember in an exam, because the Doppler formula is very heavily used in astronomy to look at the shift of the wavelength, and also you can use this to calculate the speed of an object, right? Now this is called the redshift equation. Amount of you can see that on the left hand side is what we have, the redshift, which is the difference in the wavelength, that you have the shift in the wavelength divided by the original wavelength. That number that comes here is what we called as the redshift of an object, right? Now if you multiply that redshift value by the velocity of light, you can take the speed of a particular object. Now this is why this equation is important, right? So that is something that you probably need to remember. And I have an example here. Also, if you have a particular emission line of hydrogen with originally emitted with a wavelength of 656.3 nanometers from a gas cloud, when you observe it from a telescope, you observe the wavelength as 656.6. So there is a small shift, right, in the wavelength. Now the question is, how fast is the gas cloud is moving towards or away from you? As I told you, this is a simple calculation. What you need to do is, this is the solution. Delta lambda over lambda is what we called as the redshift. I guess that is something that I have not specifically mentioned here, but it is important that you know about it. So delta lambda over lambda is what we called as the redshift of the equation, the object, and then you have to multiply it by c. This difference delta lambda comes from the difference of these two wavelengths, 656.3 and 656.6, right? And then from that you can decide the speed that a particular object is moving, right? So the second example is something similar. You can try that as well, right? So that's all about this chapter. And right, and yes, I guess now the time is almost 9:10. Now on the next day, I'm not sure actually whether I can finish everything within 1 hour on the next day as well. Maybe I will take an extra day for that as well, right? If that happens, because I feel that it may be important for you to revise these what we have done. It should be easy for you to follow them, since this is a special situation that we have been doing this course for a year now, which normally doesn't happen. Right, so I'm going to stop from here, and on the next day I will discuss with you the next chapters that we did and the important points that I expect that you should know. So that will be about the telescopes and CCD cameras. So that is the next chapter. That is about the instrumentation, the instruments that we have used, we are using in modern day astronomy, and then about the planets, right? And then we will move on to the stars. So those three sections I will try to cover on the next day. And if time permits, I am going to go through about the galaxies as well, but not sure about it. If not, I will get an extra day and online lecture like this and finish everything, like summarizing. මම ඊළඟ දවසේ ඔයගලන්ට ඇත්තටම මේ කරන්නම් මෙතන මේ 6-7 ඊළඟට තියෙන මේ 6-7-8 කියන lecture series අපි ඇත්තටම කරේ telescope ගැන සහ CCD cameras, ඒ කියන්නේ instruments කොහොමද use කරන්නේ මේ astronomy observations වලට. දැන් මේ අලුතෙන් use කරන instruments මොනවද, ඒව කොහොමද use කරන්නේ, ඇයි ඒව වැදගත් කියන එක තමයි අපි ඇත්තටම කතා කරන්නේ ඊළඟ next section එකේදී. සහ අපි ඊට පස්සේ stars ගැන කතා කරන්න යනවා. තරුවල තියෙන property එකක් find magnitude එක. මේවා ඇත්තටම ගොඩක් important ඔයගලන්ගේ exam එකට. තරුවල magnitude එක කොහොමද find color එක these are very simple calculations, but still you should know these terms. So that's why I'm trying to remind you. So on the next day, I will cover the sections about the stars, planets, and about these CCD cameras and telescopes. And on the so I probably will need another one extra session to talk about the galaxies and the cosmology part. So there will be maybe 2 sessions. All right, so there is a request telling that we do not have lectures, that if possible we can continue. I can actually continue, there is no issue with that. So let me just continue for some time, then we'll probably make it finish a little bit more, right? Thank you for that. Overall, card of lectures, right? So I assume that then you do not have lectures, right? කාටට lectures කියනවා නම් මට කියන්න මට message එකක් ඔයගොල්ලන්ගේ lectures නැහැ කියලා so that I can continue it. Right? මට continue කරන්න පුළුවන් ගැටලුවක් නැහැ. Right? I think that will be easy for you as well. And හරි මම හිතන තව ටිකක් මේක start කරන් යන්න මම plan කරපු ටික. However, I am not going to finish everything in one day, right? Because that's not going to work. And you will lose the concentration after some time. Right? එහෙනම් මම පොඩ්ඩක් මේක ඊළඟ section එකකට යන්නම්. උගල lectures නැති නිසා. Let me go to the next section that will be about right. So that will be about, so we talk about the radiation and spectra, and then so actually the next one is about the planets. Now this reminds me that one of you have asked whether you need to submit a hard copy of that poster. I think for the time being, it is okay even if you let me do it in this way. I think for the time being, depending on the situation, it may be easier to get the sorts of copies, and because of that, I will waive it, and I will have a separate section for you to submit soft copies. But if any of you do not have computer facilities and you still need to submit the hard copy, you are free to do that, right? So I will give you the both options. So if you submit the soft copy, you don't need to submit the hard copy. So let me do it in that way. So I'm going to create a new section, assignment section for that, for you to submit it. Initially, I was actually planning to get it as a hard copy, but I think depending on this situation, we may probably go for soft copies. But if you do not have facilities to do that, you can still submit a hard copy, and I will let you know how to submit it. Right? Now, for the planets, we have actually basically talked about this section about, let me see. Yes, I think I missed this section about the telescope and instruments. Sorry. Now, under the astronomical instruments, main instruments යටතේ අපි අත්‍තරම ඉගෙන ගත්තේ මොනවද telescope, what is a telescope and why we use it, and what kind of telescope that we are using, and different types of telescopes, මේ වගේ දේවල්. එතකොට astronomy වල මේ instrumentation side එකේ අපිට basically අපි use කරන්නේ, we use telescopes to collect light, and then there is an instrument that is attached to the telescope that sorts incoming radiation by wavelength, and then detectors, devices that sense the radiation. So those are the three basic parts. And so some history about the telescopes and why we use telescopes, like the functions. But what is important here is the properties. So I always actually prefer to, go for this application part. දැන් එතන ටෙලස්කෝප් එකක් අපි පාවිච්චි කරන එකෙන් අදහස් කරන්නේ මේ ලයිට් ගැදරින් පවර් එක. එහෙම නැත්නම් කොච්චර අපිට ආලෝකය එකතු කරගන්න පුළුවන්ද කියන එක තමයි ගොඩක්ම වැදගත් ටෙලස්කෝප් එකක. ඒක depend වෙනවා ප්‍රධාන සාධකයක් මත. So that is the area of the device acting as the light gathering bucket. මේ අපි light ආලෝකය එකතු කරන්න පාවිච්චි කරන device එකේ වර්ගඵලය තමයි අතන වැදගත් වෙන්නේ අපිට මේ light gather කරනකොට. Now if this is a telescope, for example, if this is a telescope that use a mirror එකක් එහෙම නැත්නම් mirror එකක් use කරන telescope එකක් නම් මේ mirror එකේ area එක තමයි අපිට වැදගත් වෙන්නේ. There is an equation to find the light gathering power. That is basically the area of the circle, right? Because almost all these mirrors are circular shape. මේ circular shape එකේ mirror එකක් ගත්තට පස්සේ ඒකේ area එක තමයි ගණනය කරන්නේ කොච්චර ප්‍රමාණයක් අපි light එකතු කරනවද කියලා. If you take an example with a telescope which has a mirror of diameter equal to 4 meters. ඒ කියන්නේ අපි telescope එකක් ගත්තොත් එහෙම යාගේ mirror එකේ විස්කම්භය මීටර 4ක් නම් මේ වගේ ලොකු telescope ලෝකේ තියෙනවා. ඒ මීටර 4ක diameter එක තියෙන telescope එකට මීටර 1ක diameter එක තියෙන mirror එකක් තියෙන telescope එකට වැඩිය 16 ගුණයක් light එකතු කරන්න පුළුවන්. එකම කාලයකදී අපි ගත්තොත්. So the reason is that for 1 meter, and so that is the reason comes from the area. You can see that this d squared factor, which can be radius එකේ වර්ගය තමයි මෙතෙන් තියෙන්නේ, right? So which means this comes as a d square factor, and because of that අපි හිතුවත් මීටර 1යි මීටර 4යි ගත්තොත් 4 වර්ගය 16. ඒකට 16 ගුණයක් වැඩි light එකතු කරන්න පුළුවන්. මීටර 1යි මීටර 3යි ගත්තොත් 9 ගුණයක් වැඩි light එකතු කරන්න පුළුවන්, right? So that is the idea. So that is something important that you probably will be useful for you. And so I have some examples here as well in calculations. The only decisive factor is here, as I told you, the diameter of the mirror, right? And basically in the market we have two types of telescopes. The first one is a refracting telescope. So that means that you use the refraction. ආලෝකයේ වර්ධනය පාවිච්චි කරලා other telescopes තියෙනවා. ඒවට කියනවා refracting telescopes කියලා. හැබැයි දැන් ලෝකයේ the most astronomical telescopes today are actually reflecting telescopes. Both amateur and professional. දැන් ඇත්තටම ලෝකේ ගොඩක් පාවිච්චි වෙන්නේ reflecting telescope වාක්‍ය පරාවර්තක දුරේක්ෂ කියන ඒවා. ඒ කියන්නේ අපි mirror එකක් පාවිච්චි කරලා ආලෝකය පරාවර්තනය කරලා ගන්න telescope තමයි ඇත්තටම වැඩිම ලෝකේ පාවිච්චි වෙන දැනට. නමුත් ඇත්තට මම දැකලා තියෙනවා අපේ ලංකාවේ නම් ගොඩක් මේ අර refracting telescope තමයි ගොඩක් අය ගන්න උත්සාහ කරන්නේ. හේතුව පැහැදිලි මම හිතන්නේ අර දැනටත් තාමත් අර ලෝකේ තියෙනවා astronomy ගොඩාක් පොකුල්ලා නැති බලා තැන්වල මේ අර refracting telescope ලෝකේ මුලින්ම හදපු නිසා අර ඔළුවේ ටිකක් තියෙනවා telescope එකක් ඒ විදිහේ වෙන්න ඕනේ කියලා. However, the truth is that now the reflecting telescopes are more popular and more widely available in the market. මේකට අතර හේතුවක් තියෙනවා. මේ තියෙන refracting telescope එකක් සහ reflecting telescope එකක් basically වැඩ කරන විදිහ ඔයගලට පේනවා. reflecting, the refractor is actually based on the refraction from two lenses, right? There is one lens here and the other lens right here to the eye. However, the reflecting telescopes are actually something like that. There is a mirror, usually a parabolic type mirror. It can reflect the light in this way, and there is a secondary mirror right here, which is positions at an angle of 45 degrees, which can reflect again the gathered light to an eyepiece, that you can keep the eye here and look at the object. මේක තමයි සාමාන්‍ය reflecting telescope එක පාවිච්චි කරද්දී මේක තමයි ඇත්තටම ගොඩක් popular. මේ ඇත්තටම මේක ඇත්තටම focusing mechanisms වෙනස් වෙන වෙලාව අදුන cascade focus කියලා වෙනම එකක් තියෙනවා ඇත්තටම මේකේ focusing mechanism එක. I mean, I'm not going to go to the details about that. But this is important, right? දැන් මම ඇත්තටම ඔයගොල්ලෝ කිව්වා practically මේ reflecting telescope තමයි දැන් ගොඩක් පාවිච්චි කරන refractors ගොඩක් පාවිච්චි වෙන්නේ නැහැ ලෝකවල. So there should be a reason for that. මේකට හේතුවක් තියෙනවා නේ. So that reason is explained here. Why we use reflecting telescope rather than refracting telescopes in the modern days. So I expect that I mean, somehow reflecting telescope you should, I mean, at least should know the basic idea why we do that. Right? The reason is actually there is something called when you do the refraction, there is something called chromatic aberration that happens. That means a different amount of light undergoes different amount of angles or bendings, right? So that will blur the object. Lens may refract කරනකොට අර එක ඔයගොල්ලෝ දන්නවා සුදු ආලෝකයේ ආලෝක වර්ග there are 7 wavelengths, right? එතකොට මේකේ there is an effect called chromatic aberration. I mean, you can search it in the internet. අනිත් එක තමයි lens එකක් through මේ light එකක් lens එකෙන් absorb කරනවා සමහර light. So that is a problem as well. And the other one is you cannot make very large lenses. It is hard to support these large lenses from its edges. මොකද lens එකක් හදනකොට ඔයගොල්ලෝ දන්නවා මේකේ එළියෙන් තුනී වෙනවා. ඒක ලොකු lens එකක් හදන්න ගියොත් එහෙම ලොකු telescope එකකට ඒක අර deform වෙන්න තියෙන එකට ගොඩක් වැඩි. So these are the reasons. And also in terms of the cost wise, cost එක විදිහට ගත්තොත් ඇත්තම ලොකු telescope හදනකොට මේ mirrors පාවිච්චි කරන එක ලාභයි අනිත් මේ වගේ පොඩි මේ lenses පාවිච්චි කරනකොට වැඩියි. And I have given some guide to how to choose your own telescope here. So there are actually a lot of details which I guess we don't have time to discuss each and everything. But what I have highlighted here is actually more what are more important. And here is what's happening in the telescope industry in nowadays, in modern days. And you can see this is a huge mirror, right? Now we have the technology to curve and make these kind of huge mirrors to build these very large telescopes, right? To look at objects that are so far away. Now this is actually the primary mirror of the large telescope which is built in European Southern Observatory, and this is called EPUN. Now this is actually these mirrors, they need to recoat again and again to maintain this reflectivity. So this is like an event that they are recoating this from the aluminium. Now, when you look at this reflecting telescope, there are very large telescopes now in the modern days. I have explained all these things to you. Very huge telescopes. And when you have a telescope, there is another thing that is very important. Telescope එක අතරම වැදගත්. mirror එකේ size එක අපි reflector එකක්ද refractor telescope එකද select කරන්නේ. අය reflectors පාවිච්චි කරන්න කියන එකත් වැදගත්. තවත් ඉතාමත් වැදගත් දෙයක් තියෙනවා. අපි හොඳම telescope එකක් තිබ්බත් කරන්නේ අපි ඒක කිල්ල මේ town එකක් මැද්දේ වගේ තිබ්බත් අපිට මොනවත් බලන්න බෑ light pollution නිසා නේ. So because of that, even you make the world's best telescope, it is not worth if you do not pick the best observing site or the best location for the telescope. මෙන්න මේ telescope එක අපි locate කරනකොට ඇත්තටම බලන්න ඕනේ දේවල් කීපයක් තියෙනවා. එකක් තමයි weather condition එක. දැන් ඇත්තටම අපිට දැන් ලංකාවේ තියෙන ප්‍රශ්නයක් තමයි මේ දිගටම වැස්ස තිබ්බොත් telescope එකක් තිබ්බට ඒක observe කරන්න බෑනේ. ඒ වගේ ප්‍රශ්න. So when you pick a best observing site, you have to consider those things, right? the most obvious limitation is weather condition. Cloud, wind, rain. All these things are important, right? සාමාන්‍යයෙන් අපි ලොකු ටෙලස්කෝප් එකක් බිල්ඩ් කරන්න යනවා නම් අපි සාමාන්‍යයෙන් ඒකේ ස්ටඩි එකක් කරනවා at least 75% of the time. ඒ කියන්නේ කාලයේ 75% ප්‍රමාණයකවත් අපිට තියෙනවනේ මේ clear weather එකක්, blue skies එක. ඒක සාමාන්‍ය කන්සිඩර් කරන එකක්. සමහරක් වෙලාවට මේ ඇත්තටම weather එක clear වුණත් මේ ගොඩක් වෙලාවට මේ ඇට්මොස්ෆියර් එකේ තියෙන ඉෆෙක්ට් නිසා ගොඩාක් ලයිට් ඇබ්සෝබ් කරනවා ඇට්මොස්ෆියර් එකේ දැන් ඉන්ෆ්‍රාරෙඩ් වගේ ඇත්තටම අමාරුයි ගන්න and also if there are a lot of water vapor ඒ කියන්නේ ජල වාෂ්ප ගොඩක් තියෙනවා නම් ඒත් අමාරුයි ඔබ්සර්වේෂන්ස් කරන්න. ඒ නිසා සාමාන්‍ය ඇස්ට්‍රොනොමර්ස්ලා යූස් කරන්නේ ගොඩක් වෙලාවට මේ dry sites ඒ කියන්නේ ආර්ද්‍රතාවය අඩු ප්‍රදේශ තමයි පාවිච්චි කරන්නේ. මේ වගේ ගොඩක් වෙලාවට හම්බ වෙන්නේ මේ කඳු මුදුන් වල. ඒ කියන්නේ altitude එක ගොඩක් වැඩි තැන් වල. ඒ නිසා ඔයගොල්ලන් so if you go and look at very large observatories in the whole world, they are always put in a mountain, right? So we have the telescopes in Mount K.V.S, which is in Hawaii, and then in Arizona, Kitt-Peak National Observatories in the Kitt-Peak Mountains. ඒක හැමතිස්සෙම ගොඩක් වෙලාවට කඳු මුදුන් වල තමයි මේවා ලොකේට් කරන්නේ. ඒ හේතුව මේ humidity එක අඩු තැනක් වෙන්න ඕනේ. And the other thing is sky එක dark වෙන්න ඕනේ. දැන් මේ town එකකට අපි telescope එකක් ඇත්තටම ගහන එක challenging වෙන්නේ ඒකයි. මොකද light pollution නිසා අපිට ගොඩාක් faint objects බලා ගන්න අමාරු වෙනවා. දැන් ඔයගොල්ලෝ ගෙට කියලා බැලුවොත් බලන්න ඔයගොල්ලෝ කමක් ඉන්නවා නම් කොච්චරක් කරුපේවද සහ town එකකට කියලා බැලුවොත් ඔයගොල්ලන්ට තාරකාවක් පේන්නේ නැහැ ඇත්තටම PHY එකෙන්. That is also a problem, right? Like that I have mentioned like 4 main factors that affects when you need to that you need to consider when you pick a observing site. තව දෙයක් තමයි මේ ටෙලස්කෝප් එකක් පාවිච්චි කරනකොට මේ diffraction limit එක කියන එක. diffraction limit එක කියන්නේ objects දෙකක් ළඟ වෙන් කළ අඳුර ගන්න තියෙන හැකියාව. යාට මේක this is measured by something called resolving power, and there is actually a equation for that. Theta is approximately equal to lambda over d, and some people use write this as 1.22 times lambda over d as well. Now from this equation, if you have done physics, you probably know this equation as well. මේ equation එක ඇත්තටම ඔයාලට මතක තියාගන්න ඕනේ equation එකක් මේ astronomy කරනකොට resolving power එක. මේකෙන් තමයි ඇත්තටම තීරණය කරන්නේ objects දෙකක් වෙන් කළ අඳුර ගන්න පුළුවන් හැකියාව කොච්චරද telescope එකට තියෙන එක. Now you can see that depends on 2 factors. What kind of wavelength that you are looking at and the diameter of the mirror. mirror එකේ diameter එකයි ඔයගොල්ලන් පාවිච්චි කරන wavelength එක දෙකම බලපානවා, right? So this is why when you build a very large telescope, diameter increases, this angle decreases, right? Theta decreases, which means you will get a good resolving power. So that is another property that you can use. මේ ඇත්තටම මේ high resolution මේ astronomical image quality එක වැඩි කරන්න පාවිච්චි කරන methods වගේක් තියෙනවා. මේ active optics, adaptive optics කියලා speckle interferometry කියන්නේ methods තුන. And the next one, probably I think I'm going to stop from this particular section right here by අනිත් තමයි මේ telescope වලට අමතරව telescope එක වැදගත්, මොන type එකද කියන එක වැදගත්, observing site එක වැදගත්. ඊට පස්සේ අපි දැන් සාමාන්‍යයෙන් telescope එකක් පාවිච්චි කරනකොට use අපි ඇහැ තියලා බලුවට ඇත්තටම professional astronomersලා මේක කරන්නේ detectors පාවිච්චි කරලා. detector එකක් කියන්නේ අපි ඇහැ විතර පාවිච්චි කරන ඇහත් ඇත්තටම detector එකක්. So the human eye is the usually that we use as the detector. But then when the photography developed, now we are using CCD cameras as detectors. මේ CCD cameras ඇත්තටම use කරන එකේ advantages තියෙනවා. And also the filters, right? Filters කියන්නේ අපි එක wavelength එකක් බලන්න ඕන නම් filter එකක් දානවා, filter එක තුල තමයි බලන්නේ. ඊට අමතරව මේ electronic detectors එහෙම නැත්නම් CCD cameras අපි use කරන ගොඩාක් දැන් මේ astronomical charge coupled devices, and there is an advantage of using CCD cameras. Right? Now I have mentioned that here CCDs have special advantages. Now, so that is something that you should know why we use CCDs, right? Because CCDs are like a very important factor now in modern day astronomy. In each and every professional grade observatory and telescope use the CCD chip for their observations. That's because they are very efficient and provide accurate measurements. And I have mentioned why we use CCDs here. So that's actually something important that I guess you should probably keep an eye on it. Why you use CCD cameras? Because there are other cameras, no? So there should be a specific reason for that. And then I have a little bit, details about the spectroscopy and the radio telescopes, different types of radio telescopes, and what else we have. And this is what I have mentioned, stratoscopic observatory for infrared astronomy, SOFIA. And this is the only telescope that is in the world which is located in a Boeing 777 jet plane, right? And this can, move around like a moving observatory. Normally it has to be located in a certain place, but this is a moving observatory that goes with the plane and do observations, which is one special observatory in the world. And then we have details about the Hubble Space Telescope and those kind of things, yes. Now there are two next generation telescopes that I have mentioned, LSST and the James Webb telescope is the other one. Yes. Now just to let you know as fact, this is the next era of the astronomy, the James Webb telescope, and this will replace Hubble Space Telescope. And James Webb is now ready to launch, and this has been moved into the launching place now. And I guess if everything goes okay, James Webb telescope should be launched within this month, and you will see this in the news when it is launched. All the mirrors and everything is fixed, and everything is, I guess, ready. And they are doing some final testing, as far as I know, to launch the telescope. And this will be the space hopefully within this month. And this will actually, astronomers and physicists expect that this will change the field of astronomy, how we look at objects and everything, because of the enormous capabilities that this particular telescope has. And you probably have heard how Hubble Space Telescope has changed the world and changed the field of astronomy and cosmology in early 1990s. And after 30 years, we expect that the James Webb will change and will discover a lot of mysteries in the universe within the next decade or two. And hopefully this was delayed, and now it will be, I guess it will start, probably it will be launched within this month, as far as I know. Right. So I'm going to stop from here because I guess I've been doing too much, maybe it doesn't help. And on the next day, I will actually try to do another online session if we cannot meet physically. I think if we don't want and we don't have to actually meet, if all of you are okay, I can do it in online like this. So I will be talking with you about a little bit about the planets, not much, and the properties of the stars, and then about the HR diagrams and galaxies, right? So those kind of stuff we will talk on the next day. I guess I will be stopping right now. Its time is already 9:36. Anybody have any questions that you have to ask from me? කාටද ප්‍රශ්නයක් තියෙනවද අහන්න මගෙන්? And the other things, actually, these are extra sessions that I just do as a help for you. Because of that, I mean, if you don't want this, then you can also tell that, right? So I can stop it at any time, because these are like extra lectures that I am doing just to help you as the course is spread too long, so I thought that maybe I should revise everything within 2 or 3 sessions for you. So we will have another one or two sessions to finish this up, if this procedure helps you, right? Right, so if you do not have questions, once again, please remember that you have to submit at least 2 projects out of 3 observations, but those who have all 3 will have another advantage, because I will take the 2 highest marks, and then for the MCQ assessments 1 and 2, I will get the one that you have the highest marks, whatever you have the highest marks. And as I told you, if there are students who haven't done any of these MCQ assessments, you can request from me for another one if you need, but by 6th of December, right? After that, I'm going to finalize all the marks for your exams. And remember that 70% of your marks will come from the final, and other 30% will come from these assessments, right? That's how it works. And for this poster, I am going to open another assignment session so that you can submit the soft copies. Initially, the plan was, as Susit mentioned, plan was to submit it through as a hard copy when you come into the classes. But I think now, depending on the situation, I will change it. You can submit the soft copies, and if anybody needs to submit the hard copy and prefer to submit the hard copy, you can still do that, and I will let you know in future how to submit it. Like most probably it will be on the exam day, but I mean, I will let you know about it. Right. So if you do not have any questions, I am going to stop right now. මම ඔයගොල්ලන්ට ප්‍රශ්නයක් නැත්නම් එතකොට මම දැන් නවත්තනවා. ප්‍රශ්නයක් තියෙනවා නම් කරුවේ අහන්න පුළුවන්. Right. Right, මම හිතන්නේ ඔයගොල්ලන්ට ප්‍රශ්නයක් නැති බවයි වෙන්නේ. So let me stop the lecture for now. And I will put another date and we'll let you know the date if it comes before the next Friday, right? If not, we will do it in the same as mentioned in the timetable on the next Friday as usual. Right, so then thank you for joining, and let me stop sharing and stop the session as you do not have any questions. You can also post to the WhatsApp group if you have any questions, right? I will answer for those as well.